we were we were doing energetics, and we had started talking about the definitions of enthalpy changes. The first one being that we started talking about that we would label enthalpy changes. We would give them different names, and according to the reactions that according to the reaction that happens. The first one was standard enthalpy change of formation. So this was the energy that was released or absorbed when 1 mole of a substance is formed from its elements, and they need to be in their standard states. So whenever you have 1 mole of a
Yeah.
substance that's being formed from its elements, that was called standard enthalpy change of formation. Then we talked about the enthalpy change of combustion. This was whenever 1 mole of a substance burns in excess oxygen to produce whatever is going to be produced. For example, for ethanol, if it burns in oxygen, it's going to produce carbon dioxide and H2O. For butane, you had an enthalpy of combustion. For hydrogen, you had an enthalpy of combustion. The condition was that this needs to be 1 mole. The substance being burnt, it needs to be 1 mole, and it's always going to be exothermic, right?
Yeah.
And we talked about enthalpy change of atomization, which was that in this 1 mole of atoms were formed, gaseous atoms, uh, from its element in its standard state. So if you're making oxygen atoms from oxygen at room temperature, it's O2. You're making sodium gaseous atoms from sodium, so you're breaking bonds. You're making
Yeah.
chlorine. You're making carbon atoms from carbon, which is solid at room temperature, so you're breaking bonds. It's always going to be endothermic, and the definition was that it's always going to be endothermic because you're always breaking bonds.
Yeah.
This is probably incorrect. I don't know why I was writing this. This let me correct this.
Okay.
Nee, just where was the definition that we wrote? As the definition came over here. It was the energy needed to form 1 mole of gaseous atoms. I mean, this one is a definition of something else
Oh,
which we wrote earlier. Gaseous atoms from elements. Okay, that should be sufficient. Gaseous atoms from elements in the standard state.
okay.
I say, anyways, the next one. The next one is let's talk about the standard enthalpy change of solution. So, standard enthalpy change of solution. Now, in this, what would happen is that basically you're going to dissolve 1 mole of any substance, 1 mole of solute,
Yeah.
and it would turn aqueous.
Okay.
So 1 mole of solute is basically what you're doing is you're dissolving 1 mole of solute, and any solute. So what you're doing is your the energy that would be released or absorbed. That's going to be the enthalpy change of solution. An example is that you dissolve 1 mole of NaCl, which is solid, and you add it to water, and it dissociates and mixes with water.
Okay.
So the energy that would be evolved in this reaction whether it's released or absorbed, that would be called the enthalpy change of solution. The substance
Okay.
the substance needs to be 1 mole at all cost. Only then would the definition apply. So 1 mole of any substance, if it dissolves and forms or turns aqueous, that is enthalpy change of solution. For example, you could have 1 mole of Cl2, which is a gas, and you mix it in water, and it becomes Cl2 aqueous. So the enthalpy change would be known
Okay.
as the enthalpy change of solution. Uh, and Cl2 aqueous. I mean, the substance doesn't really change; it simply dissolves. So the definition is that it's the energy released or absorbed.
Yeah.
So it could be both.
Okay.
When 1 mole of substance completely mixes or completely dissolves in water,
Mhm.
so it completely dissolves in water to form an aqueous solution. Amal, why is it going to
Okay.
be? So why would it be? So there's one question. Why is it? The first one is why is it? Why could it be endo and exo at the same time? What would be the difference if enthalpy of solution is let's say endothermic? Would it be more soluble or would it be less soluble? Would the substance dissolve easily or would it be difficult to dissolve?
Um, I think if it's endothermic, then it'll be harder because it's give actually no, it would be easier because it's taking in energy, and if it's warmer, then it will be easier to dissolve.
If it's warmer, right? I mean,
Yeah.
you're talking about endothermic, right? I mean, the
Yeah.
wa- the warmer thing makes sense. But if it's endothermic, it would be insoluble because until and unless you don't give it energy, it's not going to dissolve. Do you understand my point?
Okay.
So, I mean, the other point was correct that it's going to dissolve at higher temperatures, right? If you increase temperature, then it's going to dissolve because it requires energy. It needs energy. But if you're not giving it energy, if it's at room temperature, then it's insoluble, right? Is that clear?
Yeah.
And the other one is obviously the opposite. That exothermic, it doesn't really need energy, so it's probably going to be soluble. And it's going to be more soluble at lower temperatures.
Okay.
So more soluble at lower temperature. The second thing, why is it both? Why could it be both? Why could it have any sign? Like it could be endo, it could be exo. For example, if I take NaCl, and NaCl is a solid crystal, and I dissolve it,
Mhm.
what and when I dissolve it, the ions scatter and they dissociate, and it becomes aqueous. Right? This is what happens when NaCl is dissolved in water. So the question is, why is it? Why is it? Why could it be? Why could enthalpy of solution be endothermic or at times exothermic? Why not just why isn't it just one thing? Like combustion is always exo, atomization is always endo. So
Yeah.
what is the process of dissolving? The first thing is like dissolving any substance actually. The first thing is that the particles in the substance would attract each other, right?
Yeah.
So in this case, like if you take NaCl, it's probably going to be forming a crystal, and the crystal of NaCl. So let's say this is the crystal of NaCl, a tiny crystal of NaCl, and you're trying to dissolve this in a solution, and the solution has water in it. What is the first thing that you do when you try to dissolve NaCl in water?
Um, you mix it around.
You mix it around. And the reason you're doing that is so that the ionic bonds they scatter, they break. Like all the ions in the ionic lattice, in that tiny crystal, all the ions they break and they scatter around. So Na plus one and Cl minus one and Cl minus one and Na plus one, they all scatter, right? Is that clear?
Yeah.
And you have lots and lots of water molecules uh, that are going to be in the middle. So let's assume that there are plenty of
Yeah.
water molecules. So there are lots of water molecules that are going to come in the way. So the first step is step one. You're going to break bonds.
Yeah.
Okay, that is step one. When you try to dissolve a salt or any compound, you break bonds. You break the attractive forces that are keeping it in solid or liquid state or whatever state
Yeah.
it is in. And so when you break bonds, what is it? Is it endothermic or exothermic? I mean, the first part, is it endo or exo? You're trying to break the lattice.
Um,
I mean, what was
would it be exo
what
because
was
we're breaking bonds?
what was breaking bonds? It was actually endothermic. I mean, we did an entire exercise on that. If we go back before the definitions
Yeah.
part, we talked about every time old bonds are broken and then new bonds are formed. So the first part is endothermic, you're breaking old bonds, and the next part is actually exothermic because you're forming new bonds. I mean, is this clear?
Yeah.
So the thing that's happening over here is the first step is endothermic. What happens once the bonds are broken? What is step two? Any idea about the
Um,
dissolving process? I mean, what happens? I mean, the first step is that the ions they completely dissociate and they scatter. What happens after that?
yeah.
What's going to happen after that?
Um,
Like, what would the sodium ion do you think?
when they get mixed in with,
Okay, so the ions scatter, and remember, water
would
molecules
it
are
have
polar.
like a?
Remember, water molecules are polar. So the
Also,
next,
would the
yeah, what were you trying
so
to
would
say?
it be like the positive the oxygen because it's negative?
Yeah. So sodium ions and water molecules they start attracting each other, and that attractive force, new bonds are formed, right?
Yeah.
That's the next part. New bonds are formed. So the sodium ions previously they were attracting
Yeah.
Cl ions, but because of your vigorous stirring, the Cl ions they broke away and they scattered, right? And sodium ions instead started
Yeah.
attracting the water molecules, right? So a new bond is formed.
Yeah.
And when you form new bonds,
Mhm.
that part is exothermic, right?
Yeah.
So when do you think a substance would be soluble? If it has a stronger lattice or a weaker lattice? I mean, the whole reaction involves two steps. First one is you break the old lattice, old bonds, whatever they are, and then you form new bonds, right? So, Amal, when do you think, the question is, when do you think a substance is going to be soluble? Would it, if it's easy to break bonds,
Mm,
would it be more soluble or less soluble?
yeah.
What do you think? Is it going to be more soluble or less soluble if it becomes easy to break bonds? Hello, Amal, can you hear me?